live now. It will. It will. Okay. Hello, everybody. Please kindly check if. Okay. Please, if you can hear me, can you quickly comment? Okay, kindly share the link to as many persons as possible. Okay, can we do that immediately? Okay, so today you can see my setting is quite different today. So we are going to be looking at electrostatics. Now, electrostatics simply talks about charge, static charge. So the word electrostatic means when charges are statics. Now there are two aspects of electricity. We have electrostatics, then we also have electricity. Now electricity is simply talking about current charges. What that means is charges in motion. So when you have charges in motion, we call that electricity. That is a topic on its own. But this time around, we are talking about electrostatics, which means static charges. Charges that are static. Okay, now when we say charges, what are charges, or what does it mean for a body to be charged? Now, for a body to be charged simply means that the body carries charges. A body is charged when it loses or gains electrons. Okay, so and we have two kinds of charges. We have positive charges and we have negative charges. Okay, so a body is positively charged when it loses some electrons, and while a body is negatively charged when it gains some electrons. Okay, so the word charges has to do with something that is not neutral, and we have charges all around us. We see charges all around us. Now, some examples of charges you see. There is this play we usually have in primary school, I think also in secondary, where you take your biro and you rub it on your hair, then you can use that to pick a piece of paper. It attracts a piece of paper. I'm very sure that many of you have the experience or know what I'm talking about. Okay, so that is static charges. Now, another example of static charges I like to talk about is the issue of you should have seen this. Sometimes I experience this when I climb on my bed and I rub my bed. I notice there are sparks. I'm sure you must have noticed that. Those are charges. Those are charges, static charges. Okay, they are charges, but they are not in motion, not like electricity. Okay. Another example, sometimes when I teach, or sometimes when I go to shake somebody, I notice that we both have this shock. We both have this spark. Sometimes even the spark becomes very audible. I'm very sure that many of you know what I'm talking about. You should have experienced that. So all of these things are all charges. And in this topic, this is what we want to learn about charges. So we have positive charge and we have negative charges. Okay? Now this is very important. The first thing I'm going to be talking about here is how to produce charges. How to produce charges. Now, there are three ways by which charges are produced, at least for our level. Now, the first way charges are produced is by friction. We can produce charges using friction. The second way charges are produced is by what we call contact. Contact is the second way. Then the third way by which charges is produced is by what we call induction. Now, you can also call it electrostatic induction. You know, you can say electrostatic induction or just basically induction. Now, these are the three ways. By friction simply means rubbing one body against another. And there is this particular example that is very common in your exams, very, very common, is what we call rubbing glass rod. Rubbing glass rod. Rubbing glass rod with ebonite rod. Sorry, rubbing glass rod with silk. Then the other example is rubbing ebonite rod with 4. Okay, now usually these are the examples that is given, especially when it has to do with exams. I mean, for those preparing for JAM, WAEC, NECO exams. Now, when you rub a glass rod with silk, what do you expect? Now, the glass rod here, in this case, will lose some electrons and become negatively charged. So at the end of the day, the glass rod is going to be negatively charged. Okay? And while the silk, of course, if the glass rod is negatively charged, the silk will become positively charged. But more importantly, they are interested in that of the glass rod. Because, the glass rod becomes positively charged. Sorry about that. Kindly correct that. Okay? Now, but when you rub ebonite rod with 4, the ebonite rod gains electron from 4 and becomes negatively charged. So, if I were you, I could find a mnemonic in order to remember this. Okay? Glass rod with silk gives positive charge. Okay? But ebonite rod with 4 gives negative charge. Maybe something like GSP, right? And EFN, you can find something around it. Find a mnemonics. Glass rod, with silk gives positive charge. Ebonite rod with 4 gives negative charge. But the point here is that when two things come in contact, it can be charged. And that's the reason why when two things rub against each other, charges can be formed, charges can be produced. Okay? And these are the major examples as far as your exams are concerned. I hope that makes sense. So that is it for friction. Now, don't forget that if you have any question, you can always post the question on the group. I am here and I'm watching. Okay, I will appreciate your questions. I will appreciate your comments, and make sure you're commenting, find something to say. And I guess that will help our class. Okay, so the next way by which it is produced is by contact. Now, contact means that when you bring two objects together, let's assume I have this standing on an insulator. Okay, this is a neutral body, a neutral object. So let me call it a neutral body. And I bring, let's say, an ebonite rod close to it. Okay, let me use a glass rod that is positively charged close to it. Now, because they are in contact, naturally, the positive charge will flow. What you will notice is that after, you're going to have something like this. And this is your rod. The number of positive charges here will reduce, and why some must have been transferred to this. Okay? And that's the same thing with negative charge. If the rod was negative charge, it will transfer negative charge to this also. Okay? That is very, very important. But one of the things you must know about contact is that contact brings about the same kind of charge. The same kind of charge. So that means if you bring a positive charge and bring it in contact with a neutral body, the net charge will be positive. Both the neutral body and the object you brought in contact with it, the both of them are going to be carrying the same charge. If the object that is charged brought to the neutral body is positive, it means that the whole system is going to be positive. But if it is negative, it simply means that the whole system is going to be negative. Okay, somebody's asking me to move up a bit. Okay. Even though I'm going to be leaving this video, so you can always come to it. But I like the fact that you're writing. Okay, somebody's telling me well done. Thank you, Miracle. Thank you. Every other person, please make sure you comment. You have a lot to learn here. Okay, so I would have to move. Okay, let me give you 5 seconds to copy this. But so far, if you understand, you can give a thumbs up. You can say, yes, sir, I do understand, And if you have a question, you can post. But I like to see your response. I like to be sure that you understand what I am teaching. Okay, good job, good job. Thank you, Amaka. Thank you, Samuel Bola. Okay, so that leads us to the next one, which is the third way by which you can charge this, and that is by induction. Now, the difference between contact and induction is that in induction, the object is just brought close to it. Is brought close to it, does not touch it. Contact means that they must touch. Okay. Somebody said I should repeat the contact. That's what I'm repeating. In contact, the object that is charged must come in contact, must be touching the object you want to charge. So you take an object that is already charged, you use it to touch the object that you want to charge. And because they are touching each other, there will be free flow of electrons, excess charges. Like this one has excess positive charge, so it's going to flow into this naturally. They are just going to be, it's just going to be together as though they are together. Everybody is going to be positively charged. But in the case of induction, you don't bring it close. You don't touch it. You just bring it close. Okay, let me bring it a bit closer. And let's say that this is positively charged. Watch what happens. Because you are not bringing it close, remember when you say a body is neutral, neutral does not necessarily mean that that body does not have any charge. When you say a body is neutral, it means that it has equal number of positive and negative charges so that they cancel each other. Equal number of positive and negative charges. So they cancel each other. So if, let's say, a body has 5 positive charge and 5 negative charge, what that simply means is that it will be neutral because the 5 positive charge is going to neutralize the 5 negative charges. I hope you understand that. Okay, so this body that is neutral has positive charges, also has negative charges, but just that they are balanced. That's why it is neutral. So if you bring this object close to it, what would happen is that the charges here will separate. The negative charges will be more attracted to this guy that is positive, and while the positive charges will move away. Can you see that? So the negative charges part will move towards one side, attracted, because unlike charges always attract, but like charges will repel. The positive charges will move this way. Then all you need to do is either to use your finger to touch here, either a finger or a wire to touch here, and all the positive charge will flow into the ground. We call that earthing. We call that process earthing. So you touch the side, and once you touch the side, all the positive charge will flow into the ground, and what you will notice is that this guy will be negatively charged now because all the positive charges has flown to the ground. So it will not have a net negative charge. Now you can see with this, you can see another difference between induction and contact. In contact, the charge will be the same, but in induction, the charge is going to be different. Okay, I hope that makes sense. Somebody's asking, what if the ebonite rod comes with a charged body? Oh, that's an interesting question. When the ebonite rod comes with a charged body, I'm going to show you what happens, especially when we use, that's the next topic we'll be going into. It's called a Gold Leaf Electroscope. So when we get there, you'll see what really happens when it is a charged body. Okay? Yeah, so if you're writing this, you can write this. I give you 5 seconds to write this so that I can move to the next one. So you now understand friction. Friction means they must move together. You now understand contact, and you understand induction. Now, but before I move on, while some of you are still writing, I also want to give another example for friction. Another very important example for friction is cars. When cars are moving, especially trailers, when they are moving, especially during the harmattan season, they are moving against the air. They have friction with the air, and many times these trailers are very charged, and it can be very dangerous if you use your naked hand to touch the trailer. The shock is going to be so much. That's the reason why when you see some trailers, let me see if I can draw something that looks like a trailer. My drawing might not be perfect, but let me assume that this is a trailer. Okay, not just trailers, even cars. Many trailers, they always have a metal or metal iron attached to it, and that metal iron always touches the ground. The reason why that metal iron must touch the ground is because of earthing, so that it does not, somebody cannot touch it and it shocks the person. So that charge also comes by friction, going against the air. And that's the reason why when you shake somebody, it shocks you, or when you touch something, it shocks you, because you have been moving out and you have been having friction with the air. I hope that makes sense. Okay. Now somebody's asking for earthing. Now when we say earthing, now look at this. The ground, that's the ground where you and I match, is a storehouse of charges. The ground is a storehouse of charges. It is not just a storehouse of charges. It can take as many. Have you noticed that no matter how many people die, the ground has enough space to swallow them? That's the same thing with charges. Okay, so if you have a charged object, we are talking of static charges now. We are not talking of electrical current. We are talking of static charges. If you have a charge, let's say a body is charged and these charges are static, you can make this charge to go away from this body. All you just need to do, this excess charge, sorry, to go away from body, all you need to do is to connect a conductor. It can be your finger, because a human being, we humans are also conductors. So you can be your finger, but if the charge is too much, it may be quite disastrous. So you can use a wire, connect it with this and to the earth. Once you connect to the earth, what you notice is that the charge starts flowing into the earth. It starts moving into the earth. After some time, when it is done, because the earth, like I said, is a storehouse of charge. The earth is a good conductor of electricity too. It takes away all the charges from the body, and at the end of the day, the body becomes neutral. So earthing is a way to remove charges from your body, remove excess charges from your body. I hope that makes sense. If you understand my explanation, can you quickly comment while we'll move to the next thing? You can just let me know if you get it. And by the way, I appreciate your comments. Okay, yes, I can see that. So now we are going to move to something else. I believe this makes a lot of sense. Okay. So now we are going to move to something else, which, thank you, which is what we call a gold leaf electroscope. Now, please take these topics very seriously, they're exam topics. So we are quickly looking at the gold leaf electroscope. Now, what is a gold leaf electroscope? This is a device that has the following purposes. Number one, it can help us to detect charges. One of the functions of a gold leaf electroscope is to detect charges. The second function of a gold leaf electroscope is to detect the magnitude of charges. You can use it to know how large or how small the charge is, if the object is very charged or if it is not charged at all. Okay? Then the third one, the third purpose for gold leaf, please note this, the third purpose for gold leaf electroscope is to detect the type of charge. So a gold leaf electroscope is also used to detect the type of charge. When I say mean the type of charge, that means to determine if the charge is positive or if the charge is negative. Now this is interesting. Follow me and follow me well, in order for you to answer exam questions correctly. Now, the next thing I want to talk about, this is the drawing. This is what it looks like. This is what a gold leaf electroscope looks like. You have this. You have this. You have this. Okay, so this is a simple design of a gold leaf electroscope. Now this is called a brass plates. Okay, this one here is called a brass rod. This one here is called the insulator. You can just, is an insulator though. Then this one is called the gold leaf, is movable. The gold leaf, it is movable. And this is called the brass. I think I can call this the brass leaf. Then this is the container. This container, and this can also be, okay, let's leave this. NECA, what is it that you don't understand? Okay, so I hope you guys are done having that diagram. Okay, now I want to talk to you. The brass plate, for example, the brass plate is where what you use to charge the gold leaf electroscope. Now, if you, I want to say this is an exam question also. A gold leaf electroscope cannot be useful except it is charged. This is very important. Note, a gold leaf electroscope cannot be useful. Let me write it. Except it is charged. Okay, good. So you can see that we have three functions of a gold leaf electroscope. Number one, it is used to detect charges. Number two, it is used to detect the magnitude of the charge. That means how big or how small the charge is. And number three, it is used to detect the type of charge. Now, the gold leaf electroscope cannot function except it is charged. Now, the question is, how do I now know that a gold leaf electroscope is charged? This leaf is going to be open this way. This is how you know. Once you see a gold leaf electroscope that is flat like this, that means both the gold leaf and the brass leaf are joined together. It means that that gold leaf electroscope is not useful. You cannot use it to achieve what you want to achieve. It has to be like this. If it is not open, then it is not useful. Before a gold leaf electroscope can be useful, it has to be charged. And the only way you can know that it is charged is that the leaves is going to be open. Now, I'm going to explain to you why the leaves are open. That's the next thing I want to talk about. So let's see, this is what a gold leaf electroscope looks like when it is not charged. So you have this and you have this. They are just together, you know. You have your insulator here. This is just a rough sketch. And you have this. This is the first step. This is not charged. And like I said, when a gold leaf is not charged, it is not useful. Nobody can use it. Okay? Now, if you want to charge it, you can charge it by induction. I already gave you guys three methods by which you can charge. Now, this is what happens when you want to charge it. Permit my drawing. I might be slow, but make sure you understand it. I bring my ebonite rod, for example, this way. Let's assume that my ebonite rod is negatively charged. I bring it close to this. Now, already, because this is negatively charged, the positive part of this plate will be attracted towards it, and the negative part will repel it. Remember, I already mentioned that. So the positive part will be attracted towards it, the negative part will repel it, and I can now earth it. Remember the purpose of earthing. The purpose of earthing is to suck away that charge. Once I connect a wire here, or once I touch here with my finger, all these negative charges will just flow down, will leave. And once that happens, and I remove, I will notice that this gold leaf is now positively charged. Now watch what happens. Okay, this is good. Now please watch what happens. Now because this is positively charged, watch. This becomes positively charged. The positive charge flows down through the brass rod like this. Everywhere is positively charged. Then when it gets to the leaf now expands because the both of them are positively charged, and because of repulsion they will expand. So that expansion is as a result of equal charges that is on the gold leaf and also on the brass leaf. I'm trying to remember the exact name. I can't remember exactly, but I will call that the brass leaf. Okay, so you can see the expansion there. That expansion indicates that the charges on the gold leaf is the same thing as the charge on this brass stand here, or brass leaf, and that is why the expansion is up there. Now that it is charged, it can now be useful. So the next thing is, how can I use a gold leaf electroscope to determine each of these charge? Are you ready now? If you understand, please, I'd like you to comment. I understand before I move on, because the next point I want to make is important. I can write here now, fully charged. This is good. Okay, somebody is asking me to explain again. Now remember, I said that a gold leaf electroscope is not useful if it is not charged. And the way that you will know that it is not charged is when the leaf is closed. When it is closed. Okay? And once it is closed, you know it is not charged. And once it is not charged, it is also not useful. We cannot use it to do any of those functions we said that it can. Okay, we can't use it to explain any of those functions we said that it can. So if I want to charge a gold leaf electroscope, all I need to do is to bring a rod, a charged rod, a rod that is already charged, and I want to charge this by induction. You know, I explained induction earlier. Now to charge this by induction means that I will bring that charge, this rod is negatively charged. I'm going to bring it close to the electroscope. Now the electroscope has positive and negative charges. Remember, I said when an object is neutral, it means it has equal number of positive and negative charges. So the positive charges will be attracted towards the negative rod, and the negative charges will repel. Can you see that? It's going to repel. And once you touch this edge, all the negative charges will flow down. That is what we call earthing. And once all the negative charges flow down, it means that what will remain on the electroscope will be positive charges. That's why you see positive charges all here. And that positive charge transfers down and causes an expansion here. The reason for this expansion is that the gold leaf is positive. This one is also positive, so they are going to repel. That repulsion is going to make it expand. Because unlike like charges will always repel, they will never come together. That's how it is open. So I now made a statement that if you want to know a gold leaf, or if you want to know an electroscope that is fully charged, the leaf will be open this way. It will be expanded. This other one will be straight, and while the other one would bend this way. There will be an expansion. And that expansion is because both of them have equal number of charges. That means one of them is positive charge this way, and the other is negative charge, positive charge also. So that's the reason for the opening up. So I'm glad that many of you already understand this. Now the question now is, how do we use the Gold Leaf Electroscope to perform each of these functions? To detect charge, to detect magnitude of charge, and to detect the type of charge. Let me start with number one, to detect charge. To detect charge. Okay. Okay, it may not be perfect. Let me start with to detect the type of charge. Detecting the type of charge. Okay, now I want to say this, withdrawing my gold leaf again. Sorry, I am boring you with my drawing, my terrible drawing. And since it is charged, it's going to look like this. And we have positive, 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 positive. And we have this. We have this. And we have this. Okay. So this is exactly what we have. Now, if I bring a rod, let me draw a table very quickly. Object, object charge. Let me use object charge, electroscope charge. Okay, then maybe I should put effect here. Okay, let me put effect here. So this is what we have. Now let's assume this is the object that we want to check the type of charge, and this is the electroscope charge, and this is the effect. Now watch this. If the object you brought close, please notice, if the object you brought close was positive and the electroscope is positive, that means the electroscope is already positively charged. What you will notice is that there will be expansion. That means the leaf will expand further. Okay, I think I should use the word expand further. Yeah, let me use the word expand further. I'm sure you know already that because positive is positive, like charges repel. So what you notice that the leaf will expand further. So if I bring an object, this is object to test. I want to test, object to test. I bring it close. If this object is positively charged and the electroscope is positively charged, this leaf will expand further. Once you see that the leaf expands further, that will help you know that the object is positively charged. So when they say if the leaf expands further, it means that the object is positively charged. That's if the gold leaf electroscope is positive. Don't forget that. And that's the same way if the object was negative and the gold leaf electroscope is also negative, what you will notice is that it will also expand further. That means as long as the charge is the same, it will expand further. So once I have my gold leaf electroscope, the first thing I will know is the charge on the gold leaf electroscope. If my gold leaf electroscope is positively charged and I bring an object close to my gold leaf electroscope and I notice that the leaf expands again, I know that that object is positively charged. If my gold leaf electroscope is negatively charged and I bring an object and it expands again, it means that that object is negatively charged. So as long as the object is the same charge as the gold leaf electroscope, expansion will continue. Hello, I hope that makes sense. Now, if the object is positive, the object charge is positive, and the gold leaf electroscope is negative, there will be collapse. Are you seeing that? If the object is negative and the gold leaf electroscope is positive, there will also be collapse. Now, please be commenting, there will also be collapse. That is very important. Now, but I want to also add this, and this is where you need to be careful. If the object was neutral and the Gold Leaf electroscope is positive, guess what? There will also be a collapse. Sadly so. And if the object is neutral and the Gold Leaf electroscope is negatively charged, there will also be a collapse. Now, this poses a problem. This poses a challenge. That means this statement now, this table I just gave, simply means that a Gold Leaf electroscope cannot be used to detect opposite charge. A Gold Leaf electroscope, I repeat myself, a Gold Leaf electroscope cannot be used to detect an opposite charge. You know why? If I bring an object close to it and the leaves collapse, do you know what that means? It means that it is either the object is opposite charged or the object is neutral. Because if the object charge is opposite, it will collapse. If the object is neutral, it will collapse. So I cannot use a Gold Leaf electroscope to tell opposite charge. That's an exam question. I can only use a Gold Leaf electroscope to tell the same charge, and that is by expansion. So a Gold Leaf electroscope is at its best when it is expanding. You can be sure the charge of the body when the Gold Leaf electroscope expands. But once it collapses, you are not sure. Okay, somebody is not seeing the table well. What do I do now? Okay, let me draw another one. Okay. But for those of you listening, if you are getting this, just comment, say, yes, I understand. I need to be sure. And is there only one person not seeing the table well? Okay, maybe I should reduce this. Can you see the table now? Okay, I like that. Somebody says, yes, I understand. If you understand it, please comment, that is very important. So don't forget, a Gold Leaf electroscope, in summary, cannot be used to detect opposite charge. It can only be used to detect the same charge. And the same charge means that it is going to expand. So once expansion happens, the same charge. If my Gold Leaf electroscope is positive and the body is positive, there will be expansion. If my Gold Leaf electroscope is negative and the body is negative, there will be expansion. Good. But once there is collapse, then there is confusion. I cannot tell, because it means that it is either the charge is opposite or the body is neutral. Okay, I like that. David is saying interesting drawing. Thank you. I'm not a good, but I appreciate that. Thank you. Okay. I hope that you understand this. You can, and from the comments I'm seeing, I love that. Okay, so I'm giving you 5 seconds to write this up so that we can move to the next thing. So while people are writing, if you have questions, you can put down the questions. Okay, I appreciate that. Charles, yeah. Ami, yes. Awesome. The joy of a teacher is that you understand. Now, the next thing I want to talk about now is how does it detect the magnitude of charge? How does it detect the magnitude of charge? Magnitude means how big or how small. Now, the size of the expansion is what tells us the magnitude of charge. Oh, somebody is not seeing the table well. Oh, because of, oh, I see. Okay, let me, oh, I understand. Okay, so let's say we have my object charge, then we have electroscope charge, then we have effect. I can use effect. So if this is positive, this will expand. Negative, this will also expand. Positive, negative, this will collapse. Negative, positive, there will also be a collapse. Then neutral, positive, there will be a collapse. Neutral and negative, there will also be a collapse. Okay. So you can write that down. It makes a lot of sense. Okay, so I am about to move to the next. Yeah, so I wanted to explain something. How does it detect the magnitude of charge? Now, the way it detects the magnitude of charge is the size of expansion. If the expansion is small, it means that the charge is small. But if the expansion is large, it means that the charge is large. That's how to know. So once the charge on the object is small, the expansion will just be a little. But once the charge on the object is large, then the expansion will be large. That's how you know the magnitude. Yeah, I believe that makes sense. That is how you know the magnitude. So this is quite interesting. I'm sure that you guys are happy being here, are blessed being here. Okay, so the next thing I want to talk about is how to store charges. Storing electric charges. Oh, sorry, I'll have to write it somewhere else. How to store charges. So, how to store charges. Now, in the laboratory, let's say, in the laboratory, we use a device called electrophorus. The name of the device is called electrophorus. So electrophorus is just an insulator. Electrophorus is an insulator, is quite round. Is an insulator, has a hole, has somewhere that you can put your charged rod. Remember what I said, that an electrophorus must be an insulator. Okay? It's an insulator. When we say insulator means something that does not conduct electricity. So all you need to do is to place that your charged rod on it. This can be either an ebonite rod or a glass rod that is charged. Let's assume that this is positively charged. You place it on your insulator, and what you notice is that this charge is going to be preserved. Okay, nothing happens to it. This insulator can also be called a dielectric. It's a kind of a capacitor. Capacitance is one of the things that we are going to be learning. Capacitance of a capacitor. Okay, yeah. So it's a type of a capacitor. Remember that if you know your physics very well, a capacitor is also a device that is used to store charges. So before the advancement of capacitors, what we had is electrophorus. What we have was electrophorus, okay? And that is very, 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 very important. Now, sometimes it can have something, for lifting. Just this is how simple it is. Let me give another drawing. You can have something like this. Let's assume that this is positively charged. This is an insulating rod. This is another way you can draw it. This is an insulator holding the positive charge, and this is the electrophorus here. So the electrophorus might also be of a charge. Either it can be anything, It can be maybe an aborite rod. It can be something that is charged. You just place it on top of it. It's going to store this. An insulator, sorry. It's going to make sure that this charge remains charged and not and does not lose its charge. So we call that electrophorus. That is very interesting. So I'm actually looking at our time. I wanted to quickly explain the last part of this topic, which is what we call thunder protector. Okay, that will be our last part. I hope I can do this in few minutes. We call that the thunder protector. There is this other name for it. I'm trying to remember. If you can remember the name, you can also chat. You can also write it there. So we have the thunder protector. It is usually placed on top of a rooftop to prevent to prevent thunder from striking down a building. No, not thunderbolts. Not thunderbolts. It's not called thunderbolts. Thunder protector is the other name. It has 3 spikes like this. Sometimes when you see high-rise building, you see it. It has 3 very sharp spikes this way. But it's not thunderbolts. Okay, I think the best is thunder protector. If I remember the better name, I will let you know. So if you have a house like this, let's say you have this. Let's assume you have a house this way. You're going to have it connected like this. Somehow it is connected to the lightning conductor. Somebody just got that. Lightning conductor. Thank you. Lightning conductor. Yes, thank you. So now this is the house, and this is the spikes. 1, 2, 3. 3 spikes like this. And it takes charges. Don't worry, I'm going to explain all of that. Now this is the connection. It must be connected to the ground. And of course, you know why it is connected to the ground. I told you that the ground is a large storehouse of charges. So it's because of earthing. E-A-R-T-H-I-N-G. Now I'm going to explain the principle of the thunder protector. This is quite important. Now the first principle in thunder protector, the first principle is what we call charge distribution. We call it charge distribution. Another word for that, we can call it point action. Now, this is an exam question. Whenever you have a body like this, look at this body, and this body is charged. Now, the charges on the body is going to be concentrated on the sharper end. That means the sharper end is going to have more charges. The other end, the charge distribution is going to be just very faint. This is an exam question. So this is what we call point action. The charge distribution on the sharp end is very high. And that's the reason why thunder protector, the end is very, very sharp. 3 spikes, very sharp at the end. The reason is so that it can get the thunder. Now, how does a thunder protector, how does a lightning conductor protect us? That's the next thing I want to talk about. And I think some persons might want to draw this, and I might need to draw this again. Just permit me, let me clear my board. I forgot to ask. I hope you guys like my board. Which one do you prefer, this one or the previous one? I actually think I prefer this one, but let me hear from you. Can you quickly type while I'm drawing? Which one do you prefer, this particular one using the board or where you see me writing on a board? Kindly comment that. I like to know so I can know what to do in our next class. This board is better, right? Okay. Ami says this board is better. Person said this board is better. Yeah, I seem to prefer this board. Any other comments, please, so I can choose from. And you have your spike. 1, 2, 3. Okay, Samuel says this one is better. Okay, beautiful. Oh, Mulap says this board is better. Okay. Yeah, I think I prefer this too. It feels personal, you know. Okay, so now this is how a lightning. Let me tell a story. Now, after this story, it was after this experience that when I hear somebody say thunder fire you, is a very serious issue. It's not a joke. I was in a house. It was in a very long back then. I was still in university, my university days. So I was in a house and somebody else, a friend, was in another room, and there was this serious strike of thunder, and he was working on his laptop and didn't know that his laptop was attracting, the laptop was charged and was attracting the thunder, and the thunder came into the room and struck the laptop. The guy was lucky that he did not die. You know, after the experience, then I now understood when somebody say thunder fire you, it's not a joke. I've seen a case where a thunder can slit a tree, a very huge tree, into two. It is very, very powerful. But one thing you should know about a thunder. Oh, Charles said he prefers the previous one. Okay, one thing you should know about thunder is that thunder is as a result of a combination of charges. The cloud carries charges. The cloud is charged. The cloud carries a positive and negative charges, and this is what happens. Now, some part of cloud can be positively charged, and some part of clouds can be negatively charged. And you know, if you notice, clouds don't stay one place. Usually they move. You know, especially when it is raining. Now, when this cloud of negative charge collide with this cloud of positive charge, what you will experience is a spark. You are going to experience a spark, and the spark is usually that spark you hear is thunder. The same spark you experience when you shake somebody and the both of you shock, that's the same spark that happens in the air that you call thunder. But it is huge because a huge amount of cloud is here, another huge amount of cloud is here, and they come together and they form that spark. You know, I wish I can tell you how this works now, but when you have a lightning conductor, like what you have here. Let me assume that this is a lightning conductor. This is sharp. Now, if this lightning conductor is positively charged and the cloud, what the lightning conductor does is that, remember, the cloud is a combination of both positive and negative charges. The lightning conductor attracts the opposite charges to itself. That means the negative charges of the cloud is going to come this way and be attracted towards the lightning conductor, and that will drive it down to the earth. Because the lightning conductor is usually connected to the earth, it drags it down to the earth. And there is nothing for the positive charge to collide with to cause a spark. So that thunder now will not, the thunder will not now strike the object. That is very, very important. So that's exactly how lightning conductor works. That means lightning conductor always carries charges, is always charged. And the charge it has determines the charge is going to attract. If the charge is positively charged, it means that it is going to attract a negative charge. If the charge is a negative charge, it means that it is going to attract a positive charge. Are you getting what I'm saying? And once it attracts, let me put it this way, let me give another diagram. Once, let's assume it is positively charged. Once it attracts a negative charges around it, it will repel the positive charges. These positive charges will go on to attract negative charges and repel positive charges. This continuous repulsion of positive charges now gives rise to what we call electric wind. That's how electric wind is formed. So we call it avalanche of electric wind is an avalanche of currents or avalanche of charges. Okay, that is how electric wind is formed. And this is all you should know about lightning conductor. Don't forget the issue of the point action. Okay, so I want to give you a few seconds to ask your question. I will be going up. I will be going off soon. And if you understand, you can also type I understand. I'm watching your comments here. If you have questions, you type it. If you understand, you say, yes, sir, I understand, you know. Then I can and by the way, I like to appreciate you guys here. And please, if you always watch my videos, I want to beg you for something. Always share it. Send it to your friends, those in secondary school. Send it to parents. Parents also send it to fellow parents so that, you know, everybody can be a blessing. It is free, you know. We are not charging for anything. It's just my way of giving back to the society. Okay, I'm waiting for the comments. Okay, somebody's asking, does it mean that thunder occurs when clouds with the same charge come together? No, when cloud with opposite charge. When you have negative charges coming together, combining with positive charge, it will cause spark. So it has to be the same charge. So the other person is asking, gold leaf best work with which method? The best way to charge a gold leaf is by induction. But you can also use contact. So two major ways, either by contact or by induction. Those are the best ways to charge a gold leaf. Okay, Charles Bernard says, I understand. Beautiful. Beautiful. I'm going to give us 1 minute, then I'll be going off. You're welcome, Zam. Okay, somebody said I didn't get the last part. I don't know which last part you did not get. Which part exactly? Okay, let me give a quick one. You have a lightning conductor. Always have 3 spikes. And the lightning conductor is always connected to the earth. Don't forget, which we call earthing. And the lightning conductor always carries a charge. It is always charged. So let's assume positive charge. So lightning conductor will attract the negative part of the cloud, the negative cloud, and will repel the positive cloud. Will repel the positive cloud. So there is nothing to cause thunder with this positive cloud. So that is how it protects us from the effect of thunder. Because thunder happens when a positive cloud collides with a negative cloud. So that's it. I hope that you understand that. But of course, there is a group. If you are just joining us for the first time, there is a group, a WhatsApp. I think I posted my number on the chat, so you can always chat me up and send me a message so I can add you to the link. I can send you the group link. I forgot to add it here, but I'll add it in next class. So you can join the group and always follow the classes. Oh, thank you, Mulap. You understand now. Okay, that's very good. Okay, thank you very, very much. Thank you very much. I'm going to stop here, and I would like you to comment how you felt about the class, how much, the class impacted you so that others can see, and I will be going off here. Thank you, thank you, thank you. See you in our next class. So our next class is going to be next week, Tuesday. We'll meet again here on this platform. Thank you very much. Bye-bye. Okay.